Hi guys, Mr. Brown here. Today I want to talk to you guys about redox reactions. First things first, redox reactions, what does it mean? So redox reaction simply means reduction and oxidation occurring at the same time in a reaction. So you're having redox, red, reduction, oxidation occurring at the same time. Transfer of electrons from the reactant to the product all happening at one time. So why is redox so difficult for students like yourself? This is the main reason why. Assigning oxidation numbers can be a little bit tricky. So the first thing you want to do today is memorize all the steps of the oxidation numbers. Assigning the oxidation numbers. So here we go. Rule number 1. Every uncombined element has an oxidation number of 0. So anytime an atom's by itself, it's going to have an oxidation number of 0 alone. Monatomic elements. Mono came from. Mon means 1. So 1 atom. Monatomic ions have oxidation numbers equal to the ionic charge. Rule number 2. Rule number 3. Easy one. We talked about this in periodic table. This should be really easy for you guys as well. So group 1 metals always have an oxidation number of +1. Remember, in group 1, you have 1 valence electrons. You want to get rid of that 1 valence electron, so it's going to have an oxidation state of +1. Group 2 metals, they want to get rid of 2 valence electrons. Get rid of 2 valence electrons, the overall state, the overall oxidation number for group 2 metals is going to be +2. Second part of the rule. Rule number 4, halogens. A little refresher, halogens are located in group 17 of the periodic table. Halogens, they have 7 valence electrons. They want to take in 1 valence electron. So halogens have an oxidation number of -1 because they want to take in 1 valence electron. Hydrogen, this is a little tricky. Hydrogen talks about +1 and -1. So one is going to be a +1, one is going to be a -1. Hydrogen is going to be a +1 anytime it is bonded with a non-metal. Or if it's a covalent bond, hydrogen is going to be +1. For ionic bonds for hydrogen, anything bonding with hydrogen is going to be ionic bond. It's going to be a -1. Rule number 6, oxygen. A really easy rule. Oxygen is going to be -2 in a compound. There is a few exceptions, such as if oxygen is bonded by itself, you're going to have a 0 for a oxidation state. Rule number 7. Okay, rule number 7, the sum of oxidation numbers in all compounds must be equivalent to 0. And rule number 8, the sum of oxidation numbers in a polyatomic ion, so many atoms bonded in a compound, is going to be equal to the charge on the ion. So let's see how these rules apply to us in chemistry in assigning oxidation numbers as well. I'm going to bring you guys in closer so we get a better look. Okay, here we go. Let's practice some oxidation numbers. First one, we have a compound PO4, 3-. So the first thing I tell my students is to realize what the sum of the total compound oxidation number is going to be. So the first thing I notice is you have that 3-. That 3- is going to tell you that's going to be the final outcome. That 3- is going to be our result for our sum. So I make equals -3 at the end. So that's written. So that tells us what our sum's equal to. We have P, we have O4. So how many molecules of P do we have? There's a 1. So P is going to have 1 molecule. P, we do not know anything about. If you look at our rules, nothing relates to P. So I'm going to call that X. Oxygen, how many molecules of oxygen do we have? We have 4. So 4 in parentheses. And we do know something about oxygen. Oxygen, according to rule number 6, oxygen is going to have a charge of -2. So minus 2 is going to be the overall charge of oxygen. Once you simply find your oxidation states for oxygen, now it's just simple math to get to the missing link of X. So let's do the math. 1x plus minus 8 equals minus 3. Solve for x. Plus 8 to both sides. Going to cancel. Then we have plus 8 to the product side. So x equals plus 5. So where would that go? That plus 5 would go at the P. And the oxygen is going to be a minus 2. There's example number 1. Example number 2 is a little easier. You're dealing with oxygen binding with itself. So anytime you have oxygen binding with itself, it's going to be an oxidation state of 0. Overall charge is going to be 0. Okay, on to example number 3. Okay, this time we're talking about S2O3 2-. Dealing with that compound, this is going to be a polyatomic ion. It has a charge in the top right corner. Therefore, it's going to tell you the sum of the oxidation states. So we have a 2- at the end. So this whole thing is going to be equal to minus 2. We have sulfur has 2 compounds of sulfur. So 2 is going to be represented there. And we have X, because we're looking for that. We have oxygen. We know something about oxygen, but we know how many compounds or how many molecules of oxygen we have as well. So oxygen has 3 molecules times a minus 2. And that's going to be equal to minus 2 as well. So 2x plus minus 6 equals minus 2. Solve for x now. Plus 6 cancels, plus 6. So 2x equals plus 4. Solve for x, divide by 2 to both sides. Divide by 2 cancels, divide by 2, x equals plus 2. So there you go. Oxygen is minus 2, and sulfur is going to be plus 2. All right, there's one for you to try. Have a good one.